Okay, thanks for coming. Especially Friday at 5 p.m. Maybe you could have been doing at work or at a bar or something like that. So thanks for coming to listen. So this talk's called Running Node in Production Systemd. It's actually, there's not much in it that's particularly Node specific. So if you don't use Node, you'll be able to translate it into other things. The main message is basically using systemd to run services. So I say, I think in fact, even on the top, sorry, I've never used one of these before, so I'm excited. Deploying is like a broad subject, but the particular focus is on running things with the init system. So my name's Luke Bond. I'm a back-end developer, mostly Node these days, Docker, containers, that sort of thing. Nowadays, moving more into DevOpsy type stuff. Once upon a time, I built this thing called Baz, which I don't do anymore because Kubernetes exists. So who needs it? But that's just something I've done in the past that's relevant. OK, so you could summarize this talk as basically, instead of using a process monitor, I recommend you use an init system, in particular systemd. That's basically the message. And I'm going to basically go through PM2 as a reference point for what many of us use and the kind of features that that gives you, and reproduce them with systemd like manually here from scratch. So the main goal of it is to dispel the myths that this is hard. Maybe, I don't know, not sure what the background is here. For some people, this is, if you know systemd and you know Linux and you're more of the DevOps side of things, there's nothing super advanced in here. But if you're a Node developer or who hasn't got a lot of Linux experience and thinks, oh, that sounds hard, I like using process monitors, then this is aimed to give you that next step, just to sort of demystify it. It's not super advanced. So yeah, it's going to be pretty much all demo after interspersed with a few slides. So if you can't follow along, don't feel you have to remember each line, right? Just the slides will be available after, but just kind of get the gist. The idea is to show that this stuff isn't that difficult. There's all the material is available on here. This is so cool. Thanks, Pedro. And I was amazed that it works in Linux even. I can go. It's cool. Whoops. OK, so let's begin. So brief background as to the kind of problem space, I guess. Process monitors, if you're not familiar with them, are things like Forever and PM2 and Mon and nodemon and these kind of things. Outside the Node world, there are other ones like gunicorn, and there are things like there's all that list up here, and their main job is basically to start your process and keep it running. If it crashes, it will start it again. That's the main thing they do. Some of them are also used for front-end stuff like watching file systems, for reloading browsers and stuff. I wouldn't know much about that. But the focus here is on the fact that they do process monitoring. And PM2 in particular is quite an advanced one. It does a bunch of things for you. Sort of three main features that it has that we're going to focus on today is process management, i.e. restarting your process when it crashes. Log management, it's just a way to centralize the logs for all the things that you run and view them in an easy way. And the way you can share ports. You can have a Node application that runs on port 8080. You can run like 4 of them, and through the magic of probably the Node cluster module internally in PM2, it will allow them all to share a port somehow. So these are the three main features that we use it for. And I think one of the other main reasons why we do use it, although it's not a feature I'm going to focus on, it's not a feature, is that I think maybe many of us Node developers don't always get root access to servers. Maybe we just have a IT team that say, here's your box, and PM2 is installed, just configure it. That's probably why they're very popular. I think it separates the access, I think. But for me, I think there's no point for them. I don't think there's anything wrong with them. I not wanted to criticize any of the tools. But if you have the choice, I say use an init system. But nothing against any of these tools in particular. OK, so why would you want to do that when PM2 and things like it work really well? So it's basically, as I was saying earlier, it's very easier than you might think if this is something that's new to you. It's always good to broaden your skill set and to learn more about the operating system on which we're all running our apps. We're running it all on Linux. And I think in the process, you learn that it's not that hard and you don't actually need a process monitor. I think another important reason is that if you are using a Node-specific tool like PM2, although you can run other things than Node apps, but something that's not that well known outside the Node ecosystem, then I think it's much better for people looking after, like sysadmins, to just do things in the same way that they do everything else. Like sysadmins have been running MySQL and Apache with init systems for years, kind of like, why do we need all these new things? I think that's another important role, just to be a little more general purpose. And when it comes to init systems, the newer versions of majority of distributions are mostly running systemd, so it's the one to choose if you go down that route. So what's an init system, briefly? It's a process that runs as PID1. So when your Linux system boots, the kernel is loaded into memory, a bunch of things I don't understand happens, but at some point, the first process is launched that is the ancestor of every other process on Linux. Its job is to like clean up zombie processes, to configure the system, and to look after your services, to start them, stop them, restart them. When the machine reboots, it'll start them again for you, this kind of thing. And as I said, we've been using init systems on Linux pre-systemd and for many, many years to run services, so it's not something particularly new. As I say, systemd is the preeminent one these days. Okay, so brief intro into systemd itself, very, very brief. Whereas in, I think, System V or System 5, I'm never sure how to say it, the init systems are predated systemd. You tend to write shell scripts to tell the init system how to start, stop, and restart your services. They tend to be shell scripts. Whereas in systemd, we write text files that are basically like ini files. If you remember those from Windows, I remember them from my youth. It's just a text file with square brackets, sections in it, key value pairs. They get placed in this directory. So if you have a system running systemd, you look in there are a bunch of unit files. Basically, we write them, we put them in there, and then we signal systemd to reload its config. That's basically the kind of workflow we'll be going through here as we explore that. So the sample app I'm going to use is one that I always use for these things, called Demo API. It's not an API at all. It's basically, you can curl it and it says hello world. But this one also says hello world and increments a counter that it returns hello world 1, hello world 2, hello world 3, so on, talking to Redis, because I want to demonstrate dependencies between services. So it's very contrived, but it gets the point across. If you want to try this yourself, obviously get these slides, follow along. What you would need is a Linux system that's running systemd. You can see from Wikipedia which ones run systemd, which is pretty much the newest or the last few versions of most distributions. And so like CentOS, it's like version 7 onwards. Ubuntu, it's, I don't know, I think it's 2014 onwards, I'm not sure. Got the list. I'm doing all this here on my own laptop rather than a VM or in the cloud, and I'm running Arch Linux that uses systemd. I would normally do, if I were doing this not as an educational piece, but I was putting together a system to sort of, I was deploying a bunch of services. I would do them with containers because that takes away some of the operating system dependency aspects of that. But I'm not going to get into that until like bonus material at the end if I have time. But I don't want to introduce too many new things and complicate it. Okay, so here's an example of first unit file. So as I said, it's an ini file. You don't need to absorb all this. You can look it up later. We just specify a description. We say it shouldn't start until the network is up. We can specify a user, working directory. It's pretty obvious stuff, yeah? And so what we do is I'm going to do this here. So I have, I've already copied this into my system control directory. So you can see here, into my systemd directory, I should say. I've got a bunch of things that are coming up later, but you can see here there's a demo API Redis, and we're using system control, which you can look up the docs for later. Oh, hang on. I forgot to do what it says here. So we copied into that directory, and then we have to do a daemon reload because we changed it. Okay? So sudo system control daemon reload. Okay, now we can do, just to show you that it's the same. So that's the same file as the previous slide, right? Whoops. Oh, man. In hindsight, I shouldn't have put all these like steps in the slides because it's really confusing to go back and forward. OK, so that's the same thing. And what we're going to do is enable it, and then start it. So what enabling does is it says to systemd, this is the service that I want you to always start. So if the machine reboots, all the things that are enabled is what it's going to start. It doesn't actually start it right now, though. So after enabling it, we start it. Start, cool. And now I can check the status of it. And we see it failed, which is as I expected anyway, because Redis isn't running. I know that because obviously I planned this. But if we look at the logs, it's like, I can't talk to Redis. I can't talk to Redis. That's to be expected because we haven't started it, right? So let's explore dependencies with systemd, which is the reason why I included Redis. I'm not going to use the clicker anymore. It's distracting me to change between. OK, so how dependencies work is there are various ways to do it, but the way we're going to do it here is to use a once equals declaration at the top of the unit file. Basically says this service requires this other service. There are various, there's once, there's requires, and they have slightly different semantics. But what once does is it means that if Redis isn't running, then it will start it when you try to start demo API. So the change that we make here is to put once equals redis.service into our unit file. So I have this, just to save my typing, I have this script copy, which copies the various versions of the unit files across for me as we go. So I say scripts copy version 2, don't worry about that. Daemon reload, and now I can do a cat. Excuse me. We can do a cat on it, and we see that this is the updated version. Systemd has picked up our changes. And if we say restart, it's a sneak peek for later. If we say we say restart, and then we check the status, we see that it's up, and there are no errors, right? So we can do curl localhost 9000. And you can see that I was practicing. We're already up to 56 hits. Cool. So by specifying once equals, it started Redis, and we're in business. So now we have dependencies working. OK, so all this is working towards the first in that list of 3 features, process monitoring, logging, and port sharing. We're still on process monitoring. Cool. So we have the dependencies. Now, how does it go handling crashes and restarts? So let's find out. If I do status, and I get the PID there, and I don't have to do sudo, because it's running as me. So if I kill that, and then do status, it's failed, right? So we haven't got process monitoring working as we would expect with PM2 and other process monitors, so we need to add that. This is just simply because we haven't told systemd to run it that way. It's not some sort of deficiency. If you try and kill it like that, it doesn't work. It's just my slides are out of date. OK, so it hasn't restarted. So we add this. If we add this section, then it's saying whenever it stops, always restart it. Delay 500 milliseconds, why not? It depends on your service, whether you want no delay or some delay. Tune it for what works for you. And start limit interval can be used to say, I only want you to try 5 times or 10 times or whatever. If you say 0, it'll just try indefinitely. So this will always restart our service. So you can configure it in many ways. This will be fine for our purposes. All right, so there's one I prepared earlier. Copy, reload. Now we'd cat just to make sure it's got the changes. You can see there that it has. So that's cool. So we reloaded. Now we need to restart that service. Cool, so it's running. It's there. If I grab that PID, 18493. Whoops. And then look at the status. The PID has changed. So we killed it, systemd detected that, and restarted it. Cool. So that's amazing. It's going to change the world. I had trouble with my projector earlier, so I'm not going to risk this restart that I did last time I did this talk, which went fine after about an awkward 3-minute delay where the projector wouldn't reconnect. Basically, this is the point in the talk where I reboot my laptop and then show you that when it starts up, because I enabled it, it works. So maybe if we have time, we can do this at the end, right? Otherwise, it's a very awkward kind of pause. But trust me, it works. That's because I enabled it. And somehow I've jumped back in my slides. It's been restarted. Cool. OK, so now that's process monitoring sorted. It restarts when we crash. It restarts when we reboot. So logging, this is the easy one. Systemd comes with this very powerful tool called journal control. And it doesn't really need much explanation. But we can, whoop, I have too many terminals. We can say journal control for our whole system. Why, you know, you don't want to see my whole system, right? But we can do journal control -u for one particular unit. Demo API Redis 1. We can see going back several days I've been running it. And you can see it there. We can do -. You can't see when it's at the bottom of the screen, can you? I do --- boot, and it will run just the logs since the last time you started. You can say --- since. Sorry. You can do --- since today. Get only the logs for today. You get the idea, right? So that you can also follow logs with -f, and that's like it'll just tail it for you, and you'll see the logs coming through as you watch. And as I said, -boot. Since you can give it all kinds of different strings to say when you. So the point I'm getting at is like if we're comparing systemd as a thing to look after your processes, then logging it's got sorted, and it's so much more powerful than anything you'll get in any init system. No criticism, sorry, to any process monitor, no criticism to them, and it's awesome. It's really powerful. So that's the easiest one. You can also do log level, like to get your console.error messages that you might get in Node. And if you want to know more, you'll get that link when you get the slides on GitHub, but I'll tweet them afterwards. There's a great journal control tutorial on DigitalOcean, just as there is a great system control tutorial on DigitalOcean. OK, so we said process monitoring, logging, and port sharing, right? So before we get to port sharing, we need to run multiple instances. So if I'm running this application on port 9000, if I just run a second one, it's going to fail because it's going to clash ports. So let's make a little modification to our unit file so that we can share ports. So if you know Node, you'll know that if you have 4 cores on and Node being single processes, you should run 4 instances. I don't know really what I was thinking when I wrote this. I was thinking maybe if you have running Redis, you should save one for that. I don't think that's really true. But for your application, decide, and for the number of cores you have, let's say 4 cores, you run 4 instances, right? But what we're going to do in this example is run 3 because that's what I wrote in my slides. The principle is the same. OK, so we're going to modify the unit file slightly and say this is the important part here. My application takes an environment variable for the port, and you have this little %i. So you'll notice we've been saying on here things like we've been demo API Redis @1. That whatever we put after the symbol, which doesn't have to be a number, is called the instance. So it means we can use the same unit file to run multiple instances of something and give them a unique name. And we can use %i, we can use that 1 in our unit file. So this will make, if we run this, it will get port 9001. So as you might guess, what I'm going to do is run 2 and 3, and it'll go in there, like so. So it's best to show you with an example that I prepared earlier. During reload, then we do a cat just so we can see that it's picked up our changes. Cool, so now we've got the new version. So what we can do is say system control enable demo API Redis 2 and 3. And then we start them. Now if we do netstat, we'll see that we have the first one still on 9,000 because we haven't restarted it, so I'm about to do that. And we have Redis, of course, and we have the 2 that we just started. So now I can do a restart on number 1. And now we have ports 9001, 9002, 9003. OK, so if I do curl 9000, that's not going to work. 9001, 2, yep, you get the idea. Cool, so now we have port sharing in an easy way. We can run as many instances of those as we want. I just did all this. Yes, it works. We've seen it. Now, now we need to be able to share the port. We're not going to do it in the same way as PM2 does it. We run sort of a simple load balancing proxy. So for this step, you'd probably use something like Nginx or HA proxy. But I feel if I'm going to get up here and say that, look, it's so easy to do all the things that PM2 does, here, install this like relatively large project, it's kind of not really, it kind of defeats my argument a little. So I'm going to go with balance, which is like a couple hundred lines of C code. It's been around forever. It's fast. It's simple. TCP load balancer. It's awesome. And it's a really simple, lightweight thing that we can do to put in there and do that job for us. And it is very much production ready. It's really, really powerful, solid tool, but you might want more flexibility. You might use something else. It's up to you. OK, so I've installed it locally. So I have which balance here. Cool, it's there. So what I can do is run this one-liner. OK, that's running. So if I do netstat, we can see that there's 9 balances there at the top. It's cut off, but it is. So I can do curl localhost 9000. It works, right? It's returning the same IP address each time, of course, because it's all running the same host. Right, so that's all well and good, but we don't want to be running, we want to run balance in a systemd way. We don't want this foreground process. So let's make a unit file for it. Here's one I ripped off Nginx and changed the exec start line and hard-coded the ports just to show you how you can do it. So we can copy that across, reload, and now we have that unit file there. Systemd knows about it. We can say system control, I need sudo, system control enable balance and start and status. We can see it's running. It's got the same line that we had before. It has no error. Things seem cool. So let's do a netstat. What am I doing for time? Awesome. So balance is, yeah, cool. So we basically have the same thing running, but set up with systemd. The astute in the audience will notice that I haven't put in restart and all that sort of stuff. Just copy that from the other unit file. You get the idea. It's just I'm going to change this in a minute anyway, so don't worry about that. OK, so I just did all that. I enabled it. I started it. Does it work? Yes, 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 yes. OK, so this is just the very basics of a very crude way to get to the same basic feature set. I'm not suggesting this is feature complete equivalent of PM2, but it's just to illustrate the point. What you might want to do on top of this is something dynamic. Balance can be configured dynamically like HA proxy and Nginx can. So you can maybe listen for services starting and stopping, and if they move ports, I don't know what. You can do something more dynamic. You can build a system easily enough. In the same way that you might do with Nginx or HA proxy. Because I'm hard coding ports in the file. I'm not doing SSL termination. I hook it up to external load. I'm not doing all this stuff. It's pretty simple example, but I'll leave that as an exercise to the reader. For me, where I would take this is to containers, because you'll notice things like I've got user Luke, home Luke, development, right? So, like, you obviously can't reuse these things without changing them. But one of the things that containers will give you is it can take away some of those aspects. You can just run the container and the path to the executable is all wound up in there, so it hides some of that from you. That's what I would do. A little brief aside. Oh, great, I have plenty of time because I'm going fast, so I will get time for the container bit. So I would, rather than do it with Docker, I find that systemd and Docker don't play well together because, I mean they appear to for a while, but you find corner cases where it's a real pain. So basically, systemd is PID1 on the system. It's the parent process of all things. It's the ruler. Docker, arguably Docker Inc., wants to be the boss of everything. Ah, I got a typo. Damn it. Docker wants to be the boss of everything. It wants to be an init system, effectively. It wants to be PID1, if you ask me. So Docker has a daemon. When you have a unit file, as we have, if we change user node index.js to docker run blah, 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 that's actually a client call to the Docker daemon, and then the daemon is going to be the parent process. So you've got systemd thinking it's in charge of everything. You've got Docker thinking it's in charge of everything. Systemd is monitoring that CLI, Docker CLI in the foreground, and when that quits, it thinks the application's quit, which it probably has. There are cases where this doesn't match up, and it's a pain. So I would go for Rocket, which is basically designed to solve this and other problems. It thinks that daemon is not the way to go. Or runc, which is the part of Docker sort of refactored out that's just the executable, just the container runtime. Having said that, I'm going to use Docker today because we can't introduce too many new things at once. I wrote this when I hadn't included that. Cool. That's all relevant. OK, so now that I've gone quite quickly, probably because I saved time on the reboot, let's go and change this with Docker. So what kind of things will we need to change in our unit files to do this with Docker? At the top, we've been saying after network.target, when what we'll need to do instead is say after Docker, and requires Docker, which means systemd's dependency resolution system will ensure that these units don't start until Docker has started. And if we've been through this. You don't need the network mon anymore because that's implied. We're also going to replace our exec start line with these multiple lines. The reason for this is if we were just to do Docker run and didn't clean it up in some way, then when that service needs to get restarted for some reason, that container with that name will still exist. So it will crash, it won't work. So we put these exec start pre-steps in there. So these, I have this minus sign in front, which means that if the error code on those commands is non-zero, it'll still proceed. It won't kill everything. So if it tries to stop and it doesn't exist, that's fine. If it tries to remove it, it doesn't exist, that's fine. If it tries to pull it and it doesn't exist, it will fail. I actually sometimes put a minus there, especially when I'm doing a talk, because it may not have Wi-Fi. That's up to you. OK, so then here's another one of the variables. So %n. So this is redis.service, so %n will be Redis. Will be demo API Redis. This is just an example. I'll show you the full unit file in a moment. Told you that. Cool. Yep. OK, so we also need to pass environment variables. We remember from the earlier slide, we had environments, Redis host equals this, and a port equals this. We need to pass those into Docker in a slightly different way. So we still have them there. But on the Docker run line, we put -env and the variable name. Without equals, we'll just pass it through from there. So yeah, does that make sense? So that should be demo API Redis. The unit files that are in the repository are correct. OK, so and we need to change this to Redis because we're going to use Docker links. If we said localhost, it would try to hit localhost inside the container, and it won't be able to talk to each other. And when we get to the unit file for the balance, for the load balancer, we're going to pass net equals host, which means that, again, so balance running inside a container won't be able to talk to the other containers on localhost. It would need to. So if we give it the host's networking, which is what that does, then localhost will mean localhost on the host. It'll become clear when we get there. If not, ask me. It's fine. OK, so here are the final ones. And so this is just all the things I said before, basically. This is the Node application. We've got our environment still there. We can still run as user. That's cool. You might, if you If you leave that out, it'll probably default to root. If you're running on CoreOS, it'll default to core, I believe. All the stuff I just said. We have the restart, the Redis one likewise, and this is the balance one, the main difference being net equals host, and we've got our same stuff there. Cool. OK, so let's try this. OK, so reload. OK, so what do I have running here at the moment? Nothing? Cool. Oh, because I haven't run anything in containers. Why would I have anything there? Netstat. I still have my other things running. So I'm going to say sudo system control stop demo API. Do I need to do that? No. I want to stop Redis. System control stop. The reason for that is because I've renamed it from Redis to docker.redis. So we'll start that in a different way. We'll disable that. And now we can do, we will enable docker.redis and docker.balance. I'll stop balance also. Stop balance, disable balance. OK. Now I can do start sudo system control start docker dot what? OK, so I'm going to start docker.balance and docker.redis. And I'm going to restart all three of my demo API Redis containers. And fingers crossed, everything will work, but it'll be in containers now. It's probably now trying to check the Docker Hub to see if there's a newer version of those containers, realize that there isn't, hopefully, or we might be here all day because I don't have network switched on. But it should only take a moment or two. So as I said earlier, when I put that minus sign after the equals so that these lines don't fail, I've added that in the unit files, I think, on, to the Docker pull line so that it will eventually time out. Let's go and have a look what's going on. OK, so we have so it seems that balance is still starting. No, balance is up. Cool. So if we were to curl localhost 9001, that would probably work. 2, 3. So the node services are up. Redis is up. Balance is maybe not up yet. Why do I have sudo on that? Damn it. Balance is up. OK. I don't know why I don't have my foreground command prompt back. But there. OK, cool. So we have Redis, balance, and our three services all running in Docker. And you can see that the round robining is working because you'll get a different IP with Docker nowadays for each of your services. So there we go. I got my command prompt back. I don't know why that took so long. OK, so just to recap, so earlier I was saying that PM2 gives you three major things: the logging, process monitoring, logging, and port sharing. We can recreate all that with pretty much basic systemd plus a load balancer. And it's easy. It's so easy you can do it that quickly. And I think it's a good idea to learn more about Linux and systemd because it's the operating system on which we're running things by and large. You can use my unit files in the repository, which I'll tweet after, and you'll see it on the screen in a minute, as a starting point, tweak them for your needs. Systemd does have a bit of a learning curve, but it isn't very difficult. The concepts are very simple, and the tools are very powerful. And you'll realize that you don't need a process monitor after all, because Thank you. Because systemd, or the init system, is basically the alter process monitor because its job is basically to monitor processes, among other things. And after all, when you reboot your system, and what starts your process monitor? Your init system, right? So why not just use that for everything? Cool, so that's where you'll find everything. All my unit files are there. That copy script, 1, 2, 3, 4, 5, 6, those 6 directories are there, so go to number 6, and you get the latest ones. And here is a list of resources I used. The journal control articles are in there. There's this one by the creator of systemd talking about security features from CoreOS Fest. That's really cool. He goes through all the things you can put in your unit files around security. So I recommend you check that out. Man pages, etc. Cool. Thanks very much. Anyone have any questions? Yeah. So systemd has a way to do with logging.
The output of Node applications like PM2s.
Yeah, so if I understand you correctly, what I was saying earlier about journal control, so we can see that here, you can use just stop me if this is not answering your question, yeah? It's not, no? So we can see the logging for an application like so? Yeah?
Yeah. Forget it, yeah.
Cool. And you can also see them all interleaved in one place. You can list multiple ones. And so if you wanted to see all of my demo API Redis units, you could list them all, and you could see them all in one go, if that's helpful. But otherwise, maybe this is what you're getting at, is that it's the logs for the whole system. So, but you can filter it down to just what you want to see. Any other questions? Cool. Thanks very much.